Hello, everyone. It's Miss Sabi here. I'm here with another video. In this video, I'm going to be addressing exponents and the exponent laws. I have a couple of my students who either they're in grade 9 and they're just starting to learn about this, or some of my grade 10 students have started the year reviewing the exponent laws because they follow you for the rest of your math career. So I wanted to take the time to go over this and actually do a video about it. So anything that I share here, I'll drop the link to the actual document. And also, like I keep on reminding you all, these videos are not professionally done. If I make a mistake, it's going to be in the video. I won't be editing it. I will make corrections or anything like that. If my phone rings, sorry. If I get an email, sorry. But again, these are just quick little videos that I put together. So instead of repeating the same things, or for students who we've talked about this in our sessions and they just can't remember and the notes aren't helpful, at least there is a video to accommodate the notes. Okay, so we are talking about exponents. Okay, so let's remind ourselves what exponents are. It's those little numbers, or in like Microsoft Word world, we would call this a superscript, right? So it goes higher up over there. So that's the exponent. Sometimes they call it the power, 2 to the power of 8. And the number that the number or the variable, sometimes it could be algebra. The number or the variable that the exponent sits on top of is called the base. Okay, so it's important to remember that. The exponent laws that you see in high school are as follows, right? Product, quotient. So remember, quotient means division. Product means you multiply. These are the different exponent laws that we see. In grade 9 in the beginning, I feel like you don't see that one too much, not too intense, right? We start working with radicals, but like not right away. So you may have not seen this yet if you're in a younger grade, but we're going to take a look at it. All right, so it's important to remember to use the product rule and the quotient rule, right? So let's go back up over here. Product rule says that if you have the same bases, you add their exponents. Quotient rule says if you have the same bases, you subtract their exponents. It's important to note that you cannot do this addition and subtraction of exponents if you do not have the same base. So if these things are different, you can't apply the quotient and product rule in that way of adding and subtracting exponents. So the other day, I was asking one of my little inherited nieces, so from a school that I used to teach in, and I call her like my niece, and she's coming to tutoring with me. I asked her, like, well, why would we use the exponent form? And she thought about it a little bit. And then I did this. So imagine having to write 2 times 2 times 2 times 2 times 2 times, however many times is this? How many times is this? 1, 2, 3, 4, 5, 6, 7, 8. Imagine having to write that, like you have to use that over and over again, and you have to write 8 times over and over again. Well, exponent putting things in exponent form saves you from that. Because then now, instead of writing 2 times 2 times 2 8 times, I can just write 2 to the power of 8. That is simpler. You won't have to lose track of how many times you've written 2 on your calculator. You can just write 2 to the power of 8 on your calculator. So speaking of that, what does that look like on some of your calculators? Well, some of your calculators will have either this little hat, right? It's a little chapeau. So you would do 2, then you would write this little thing like that. I don't even know what that's called. And then you would write 8. Okay. Some other calculators have, like mine has this. The button looks like this. And there is a little square to tell you you can put whatever power you want. So I would write, let's say 2, and then I would put that button, and then I would put 8. The other day, another one of my students, their calculator had x to the power of y. So then you would write the 2, you would press that button. So maybe I'll put boxes around it so you know that you're pressing a button. That's a button, and this is a button. And then you enter 8. Okay, so be familiar with your calculator. That could make or break you, right? Not knowing how to use your calculator. So always make sure that you have the same calculator and that you're not going into a test with a calculator that you don't normally use. Of course, if you've lost your calculator and it's an emergency, use another calculator. But try to always use your own calculator, which also means don't use your phone, right? In Quebec, it is against the law for students to bring their phones to class, so you should be using a calculator. So just a quick reminder, because in some of these instructions, I'll be referring, I'll be saying things like variables, coefficients. So the most important thing to remember is that the coefficient, right? So this here, coefficients are the numbers that appear before variables. So variables are the letters in algebra. The numbers that are in front are called coefficients. So that's important to remember. So let's look at the first law. The first law is the product's law. So remembering when we say product, what we mean by that is that we are multiplying. Okay, so the product law is multiplying. Again, let's check. We have same bases. Okay. So the first thing I tell you to do is highlight. I always tell my students, walk with highlighters, bring the highlighters to class so that you can classify things, right? If there's too much things going on, you get confused, make mistakes. So I'm going to highlight my coefficients. Okay, so these are both coefficients. And then I'm going to highlight the numbers that have the same bases and their corresponding exponents. So x cubed and x to the power of 4, those are similar or like, or whatever you want to call it. They're like because they have, not like terms, right? But they are of the same base. So because we're applying the product law, that's going to be important. So the first thing that I'm going to do is I am going to multiply the coefficients. So the coefficients are 2 and 5. So multiply those together, I get 10. Okay, I'm going to write that 10 there. Okay. Then I'm going to write the common base. The common base that they both have is the x. So let me just bring this down. Oh, that's not what I wanted to do. Bring that down. Okay, so I'm going to write the x. And then it says add their exponents. The exponent of the first one is 3. The exponent of the second one is 4. So I'm going to do 3 plus 4. And I want you to show this step, okay? In grade 9, especially in Quebec, when they're introducing this topic, they want to see that math that happens. So they don't want to see that you wrote it just like that. They want to see that you understand the laws and they want to see all those steps, okay? So then finally, I can simplify that. 10x 4 plus 3 is 7. All right, so 2x cubed times 5x to the power of 4 is 10x 7, 10x to the power of 7. That's my final answer. So that was the product law. Now let's look at the quotient or the division law. Okay, so this law says as long as you have the same bases, you can apply this law. So double check, I have the same bases. They both have y's. The first thing I always tell my students is I want you to write it, if it's written like a division like this, I want you to write it as a fraction. So instead of it being written like that, I want you to write it as a fraction. Okay, now that's going to make a little bit more sense. It's going to be easier to see what we're doing. So again, I'm going to ask you to do the same thing, highlight. So I'm going to highlight the coefficients, and then I'm going to highlight the algebraic terms. with the same base. Okay, so again, first thing, I'm going to do the same thing I did before. I'm going to divide the coefficients this time. Okay, so dividing the coefficients, what does that look like? I have 12 divided by 4, which is 3. Okay, so I'm just going to write that here. Then I'm going to write the common base, which is y, and I'm going to do the subtraction. You subtract the bottom exponent from the top. Okay, and it has to be in that order. You can't just decide to do it the other way around. You have to do it like this. So I'm going to do 8 minus 3. So again, this is being subtracted by that. Okay, so you're taking away the bottom base from the top. So I've shown that step, I've shown the math. My final answer, 8 minus 3 is 5. So 12y to the power of 8 divided by 4y to the power of 3 is 3y to the power of 5. Okay, so always trying to be as organized as possible. And even if you're not organized, circle your final answer so your teacher is not searching for it. Now we have the power of a power rule, okay? So why is this called power of a power? Well, you have a power here, and then this thing is raised, this whole expression is raised to another power, okay? So it's not apparent yet, but you should always be following BEMDAS. BEMDAS, or order of operations, or BEDMAS, or PEMDAS, whatever you want to call it, that applies to all math, right? Even if you're doing algebra, even if you're using real numbers, you're always having to take into consideration your order of operations, okay? So first thing, I have brackets here. There's nothing I can do, okay? And so next step in BEMDAS is exponents. So what you're going to do is, it's almost like a distributive property thing happening. You're going to distribute, okay, that exponent that's on the outside to everything that's in there. Okay, so power of a power. Sorry, I'll wait for that to move back up. Okay, so what does that look like after I've written that? So then now I have 2 to the power of 4. And then I have x to the power of the 3 is already there. And then I've raised it again. Okay, so you are multiplying those exponents finally. Okay, so 2 to the power of 4, right? What is 2 to the power of 4? I'm going to remind you that's 2 times 2 times 2 times 2. So you are multiplying 2 by itself 4 times. So 2 times 2 is 8. Okay, then you have 8 times 2 is 16. And 16 times 2 is 32. So over here, I have 32. Then I have x. And for power of a power, you multiply the exponent. So we're not adding, we're not subtracting, we are multiplying. So then we have 4 times 3 is 12. So this is our final answer for that one. Okay, so a lot of students forget this. They forget to distribute this to the coefficient and they apply the law only to this, but this gets distributed to everything in there. So it's important to remember that you've got to raise the coefficient to the exponent as well. Again, students forget that all the time. Okay, now we have power of a quotient. Okay, so remembering quotient means division. So it's called power of a quotient because there's a division, the operation of division happening in here. So remember, a fraction is dividing. So you're dividing this, your top by your bottom. And then there's a power outside of that. Okay, so it's called power of a quotient. So again, you're doing the same thing that we did in that other step. You're going to distribute, right, this to everything in here. Okay, so I almost lost it. It looks like a 4, that it's a 4. So again, you get it. I got to distribute it to everything in there. Okay, so what does that look like? So I have 2 to the power of 4. Then I have x to the power of 2 times 4. And on the bottom, I have 3 to the power of 4. Because remember, like, even this coefficient, this 2, these numbers have imaginary exponents, right? There's always an imaginary 1. So you're kind of doing the same thing where you're going to be doing 1 times 4. But we skip that step, okay? Because we just know it. Okay, so 3 to the power of 4. And then y to the power of 3 times the 4. All right, so what is that answer? So 2 to the power of 4, we already figured out that that's 32. Then we have x, and 4 times 2 is 8. I am not going to lie. I'm going to pull out my calculator to do this quickly because I don't want to do the math. So 3 to the power of 4 is 81. And then we have y to the power of 4 times 3 is 12. Now, it's also important to think, can these things be reduced? So this is my final answer. This is my fraction. It's a rational expression. It's a fraction. But you also have to check and see if you can reduce that, right? So see if there is a common factor between your numerator and your denominator of your coefficients, right? In this case, there is no common factor. So that is your final answer. Okay, so that's power of a quotient. So again, whatever's on the outside, it's almost like distributive property is getting distributed to everything on the inside. All right, 0 exponent. No major thing to remember, no major steps there. It's just remembering that anything to the power of 0 is 1. You can try it on your calculator. And so again, we're going to do the same thing that we did in the step before because we're distributing that 0 to everything. So we have 7 to the power of 0. X to the power of 4 times 0. Y to the power of 2 times 0. So again, remembering anything to the power of 0 is 1. So 7 to the power of 0 becomes 1. This, I'm just going to show that that step, that intermediate step, although when you become a pro, you probably skip that. So then anything to the power of 0 is 1. So x to the power of 0 becomes 1. Y to the power of 0. Sorry, I forgot that. Y to the power of 0 becomes 1. So 1 times 1 times 1 is 1. So this expression, which seemed like, oh my goodness, actually just ended up being 1. So I put an additional example here because like you're not going to be really asked to do anything like that. But what will happen is sometimes you'll do something, you'll do an exponent law, and then you'll end up with an x to the power of 0. So this is a quotient, right? So we're dividing. So the first thing we do is we realize, okay, these are coefficients, and then that color's not good. These have the same base, so I can apply exponent laws to that, okay? So first thing I'm going to do is divide the coefficients. So 10 divided by 2 is 5. Then I apply the division quotient law. I'm going to subtract the bottom from the top. So I have 5 minus 5. And then I rewrite it, 5x, 5 minus 5 is 0. So this here, let's do that. This is just 1, right? So I end up with 5 times 1, final answer, 5. Okay, so that's more of how you're going to use the 0 exponent. Okay, so anytime you end up with something to the power of 0, that just is 1, and you've got to show it. Okay, this is another one that's super important and students forget. It's the negative exponent law. So if you somehow do, not somehow, if you do the simplification and you do all the laws and you end up with a negative in your answer, you will lose marks if you leave it in negative, because we do not leave the exponents negative. So there's a way that we handle that. So first thing I'm going to do is, okay, so these are like bases. So these ones are like bases. I will highlight that. Okay, so I'll now apply the exponent laws. Write down the like base and subtract their exponents. So I have x to the power of -3 minus 2. Okay, minus 2. So because it is minus 2, so, and then, sorry, let me go ahead and write that. Okay, so x -3 minus 2 is -5. Rewrite the y squared. Then that's what we have. But look at this. This we cannot keep there. So the rule is you flip it, right? So you find the reciprocal and you get rid of the negative sign. So because this x to the -5 or -5 is in the numerator, I am now going to bring it to the bottom. So the y squared remains on top. And now I bring it down to the bottom, and you'll see there's no more negative sign. So that is the correct final answer with no negative. Okay, so pay attention. There is no more negative sign because I brought it from the top and put it on the bottom. If you had something like 2y squared over x to the -5, same thing, you're going to flip it. I am going to bring the x -5 or -5 to the top, and I'll get 2y squared. Let me just move this over so I don't run into that. 2y squared. So nothing happens to the other thing because that's fine. But this is brought up to the top, and then it's +5. Okay, so you just flip it, and then it loses its negative sign. So this is fractional exponent. Again, when you first start off learning about these exponent laws, you don't really see this, right? This is more seasoned grade 9 and then definitely grade 10 if you're in SN science kind of math, but you don't really see this in the beginning. But it's just something that, like, over here in Quebec, we're allowed memory aids for exams. So it would just be something that you put the whole formula on there. Like, where do I put all these different parts? So the fractional exponent says, so when you have something with a root sign, it's called a radical. So just paying attention to this. So we have a to the power of, and this is a fraction, right? So it's a fractional exponent. You rearrange it to look like this, okay? So the denominator of the fraction goes in the root place, and the base goes under the root sign, and the numerator goes next to the base, right, from this. So let's take a look at this example and just rearrange it how we're supposed to. So I will copy this, copy, paste, and let's rearrange. Okay, so the denominator is 2, so that's going to go here. And remembering, when you have your square root, right, and you just have the square root sign alone, there's an imaginary 2, but for square root, that's the one that we do not write it. So when I finally simplify this, I won't write the 2, it's just implied you're finding a square root. And the base is 6x to the power of 4. And the numerator, what's that? The numerator is just 1. So the simplified version of this is we have square root of 16x to the power of 4. This is not simplified, okay? This could be further simplified because these are perfect squares. I can square root this and I can square root that. So I'll end up with, so what we're looking at is square root of 16 times the square root of x to the power of 4. So what is that? The square root of 16 is 4. The square root of x to the power of 4 is x squared. So our final answer is 4x squared. Okay, so it went from looking like something super crazy and scary like that to simply 4x squared. So it's really helpful to know how to rearrange it. So again, you would just put this on your memory aid and then plug things in and making sure you're highlighting or color coordinating so you know where things go. Okay, so those are the basics of your exponential laws. So now I'm going to ask you to think about this multi-step one. And you can pause the video and try to do it. So we have a couple of things going on here, but then I'm going to say, okay, it looks overwhelming, but to keep me focused and on track, I'm just going to remember PEMDAS. Okay, let's just remember PEMDAS. So order of operation says that we do brackets, right? We do have brackets, but nothing can be done with these things alone in the brackets. So I will go on to the next priority, which says exponents. Okay, so we do have exponents. So what we're going to do is apply the power of the power of power law. So that's going to be distributed to everything in there, and that's going to be distributed to everything in there. So we have, again, that, and that. So that's the first thing that we will do. So I have 2 to the power of 2. Then I have x, -3 times 2. Then I have y, 4 times 2. And then this is going to be multiplied by x, 5 times 3, and y, -2 times 3. Okay, so I've done all the distribution, and all of that is going to be divided by 4x to the power of 12. So now I can apply and simplify even more. 2 to the power of 2 is just 4. So that's over here. That becomes 4. Then I have x to the power of -6. Okay. Then I have y to the power of 8. And this is being multiplied by x to the power of 15. And y to the power of -6. Right? And then that is all over 4x to the power of 12. Okay. Now I'm going to apply, right? I'm going to apply the product rule over here. So remembering this and this will apply the product law there, and this, because those are the ones with the same bases. So I will do that on top first. So 4, let me bring this down. So 4, then I have -6 plus 15, right? I'm adding those exponents because that's the product law. Then I have 8 plus -6. Okay, that's the product laws. And then all of that over 4x to the power of 12. So simplify again. I have 4. -6 plus 15 is like saying 15 minus 6, which is 9. And then we have y, 8 plus -6. Remember, when you have a plus and a minus, the negative wins. So it's like saying 8 minus 6. That's squared. And then I have 4x squared on the bottom. All right, so I can divide the coefficients. They cancel out, right? So 4 divided by 4 is just 1. We also can say they're canceled out. Now we're dividing. So 9 minus 12. And then we're keeping the y squared. Okay, so let me just separate that so it's not confusing. Okay, simplify. We have x, and then 9 minus 12 is -3 y squared. So that seems like it's the final answer. However, we do know, like we said before, you cannot keep this negative in there. So what are we going to do? We are going to flip it. So it goes from being on the top to the bottom. So from numerator to denominator, I keep the other term there, y squared. And then I have that. So it goes from being this crazy long thing to being simplified to this. So that's another reason why we would want to apply the exponent laws, because we get to simplify things, make things more simple. So that is it for my quick little video about exponent laws. I hope this is helpful because especially in the higher grades, this you're expected to know, and this is supposed to be the easier part in comparison to the other things that will build upon the exponent laws. So again, this is your favorite Black girl magic STEM educator, Miss Sabi. I will put a link to this document in the episode notes, or whatever you want to call it, in the video notes on YouTube. And again, if you have any questions, please don't hesitate to contact me if you notice any mistakes or anything. Again, we are all learning and we are all human, so I am not perfect, but please let me know if you do find mistakes. I will stop sharing my screen. And thank you so much. Come back soon. I will drop another video maybe next week, maybe the week after. Bye.